In this recording, we will be solving an example about PCA, Principal Component Analysis. As we discussed earlier, that sometimes we have data set with large number of variables, or sometimes we have data that the number of variables exceeds number of observations. In this case, we refer to this problem maybe as a high-dimensional data set. And to deal with this, sometimes we try to eliminate some redundant variables, but sometimes this is going to result in losing valuable information from the data. So in this case, what we do, we use many techniques. One of them is the PCA. PCA is technically dimension reduction technique, and it's effective because we reduce number of variables, but we do not eliminate or without losing, let's say, much information. So this is the idea of PCA. We will be discussing the interpretation of the PCs, the principal components variables, later, not today. Today we are just going to set up and to find the PCAs and the principal components, and we will do the analysis, but we will not discuss the further than this right now. In this data, we have United Nations conduct annual studies that measure the level of happiness among the member countries. Happiness measurements are based on survey questions such as how people feel about their life, levels of positive and negative emotion, freedom to make choices, and others. So these data are converted into numerical scores for each member country. So let's look at this first. Let's look at the data. This is the data. So we have all of these variables. We have 135 observations. We have a high number of variables, by the way. It's 8 compared to the observations, to the sample or the data we have, which is 135. And if you look at the numbers, we have the scales are different. So the household income index, it's like something between 0 and 1 here. Life expectancy is like, the range is a little bit higher. If you want to look at close eye on the structure of the data, you can use a structure function to look at the range of the data, minimum, maximum. Then this tells you the range of each variable. Before we start conducting PCA, one of the major things that we may do is scaling the data or standardizing the variables. PCA is sensitive to the scale of the data. If one variable has more variability than the other one, actually it's going to dominate the PCA. So the best idea to start working with the PCA is standardizing all of the variables before or prior performing the PCA. So that's why we're going first to standardize the variables. Now the first question says, conduct PCA on all of the variables except the country variables. Should we standardize? Yes, we should, as I said. Why? And the question says, what is the percentage of the total variability is accounted for by the first principal component? So first, let's standardize using what? Using the function called scale, and we did this in the previous recording. So I'm going to create a new data set. I'm going to call it my data standardized scale my data, but I'm going to exclude the first column. The first column contains the countries, so there's nothing to do with the country. So I'm not going to do anything with the country, so I'm going to keep it out of my analysis. So I'm creating a new data set, contains all of the variables in standardized format, so you can look at them or we can see them from there. So we did scaled the data, right? After that, what we're going to do is we're going to find the PCA for my data.st, and to do this we're going to use a function called PRCOMP. So PCA is going to be PRCOMP. It's a function that does the PCA analysis. Maybe someone's going to ask, if this function PRCOMP, does it exist in any of the library that is not installed? No, it's actually part of the base R package, so there's no need to install any libraries or additional libraries. So let's run this. ST, not sit. It's my data ST, right? Yes. So we run the PCA. After that, we can use summary function to look at this. So this will answer my first question. The first row contains, first of all, notice what? That we have 7 PCs, 7 principal components. And we have 7 variables here. We have originally 8 variables. If you take off the country, we're going to have 7 variables. So we are expecting to generate 7 principal component variables. And as I said in the previous recording, that you are going to see different variables. They are not the same the variables that we started with. They are not the life ladder, social support. No, these have different interpretations now. So we have 7, this is fine, and we have 3 rows here. We have standard deviation for each PCA, and we have the proportion of variance, and we have the cumulative proportion of variance. So for the first variable, the first principal component capture about 53% of the total variance of the data. The second one captures 20% of the total variance of the data. The third variable captures only 1%, less than 0.1% of the, it's 9% of the total variance of the data. Here is the cumulative one. So the first one captures 53% of the total variation of the data. The second one with the first one, both of them, they captures, you just add these two values, you get the second one. 73%, then you add these 3, you get the third one, and so on. So the first 3% captures 83% of the variation of your data. So if you are willing to lose 20% of your data, less than 20%, you can cancel all of the other variables. You can only study the first 3 variables. You can include the 3 variables in your studies. Or if you'd like to put more, you can stop up to the 4th variable. So up to the 4th variable, you will be able to capture 89% of the total variance of your data, right? So to answer the first question, which says, what percent of the total variability is accounted for by the first principal component, is 53%. It's 53%. So this is the answer of the first question. And we said why we need to standardize the data, because PCA is very sensitive to different units, to different variations of the data. When you have different variations, when you have different units, let's say, it's good to standardize the data. For question 2, how many principal components must be retained in order to account for at least 80% of the total variation in the total of the data? To keep 80%, we can use PC1, PC2, PC3 is enough. So the first 3 variables, or PCA variables, not the original variables, no, the principal component variables, because we just need to account for at least 80%. This one helped me to keep at least 83%, so the first 3 variables will do that job. If the question says, display the weights used to compute the first principal component scores, which original variable is given the highest weight to compute the second principal component? So this part contains 2 ideas. Number 1 is display the weights used to compute the first principal component, PC1. So to do this, we're going to go to PCA, the one that we created. If you add $, you're going to have options. So we have rotation, we have center, we have scale, we have X. So if you show rotation, what's going to be happening? So we are going to see the weights used to compute the first principal components, and the second, and the third, and the fourth, and the fifth, the sixth, and the 7th. Let's focus on the second. So I'm going to choose first and second column. It should be, let me try this. Yeah, here we go. So these are the first principal and the second principal component. So this is the idea. This is important to know. So these principal components, how we created these. This has been created based on weights of the variables. So each principal component is created by a linear combination of the variables. So what is the weight how did we create the PC1, let's say? The PC1 is created by this number times life ladder, plus this number times social support, this number times positive emotion, this number times this, and so on. So, and for each country, we're going to have values for these, then we're going to have a value for the PC1, and so etc. So these are the weights that used to create PC1, and these are the weights that created used to create PC2, right? So we are displaying the weights used to compute the first and the second PC1, PC2. So we are answering the first question, the first part. For the second part, it says which original variable is given the highest weight to compute the second principal. So if you look at, for example, to the first principal, look at the weights. Which variable contributes the most of creating PC1? you can see that the first two variables, life, ladder, social support, both, and this one, life expectancy, the three of them, especially the first one, contributed the most when we created the first variable, the PC1, principal component 1. The question doesn't ask about the first principal component, it asks about the second principal component. So which variable contributes the most of creating the second principal component variable? It's the household income index. We have about 60%, not 60%, it's about 0.59. It's about 0.59 as a weight. This contributed the most. Also, this has high contribution. Positive emotion. This has high contribution. This has low. This has low. Remember that we use standardized value. Remember, that's how we can easily do the comparison here, right? So to answer the second part, which is which original variable is given the highest weight to compute the second PC, is household income index. The very last question, which says what is the first principal component score for the first record Albania? So now we are going to look at the principal components for the, let's say, the countries. So first let's look at PCA X. What does this show us? Let's see. This shows us the principal component values or scores for each observation. First observation, second, third, fourth, etc. We have a PC1, we have PC2 for the first, for the second, etc. Right? And again, how we calculated these by simply using this equation. Multiply this times this, plus this times this, plus this times this, plus this times this, etc. What are these values from the standardized value? We just put them for each country, multiply them, you get the first score, and so on. So the question says for the Albania. For the Albania should be the first record. So the number is going to be negative 0.967. This is the principal component score for Albania. But still, we can go further and do some of the, like, we can actually add, we can create new data. Let's say new data. We can put these in data frame. Let's add the original data, the original data, and let's add this to them. Let's add this table to them. So my new data becomes like this. We have the original variables and we have their corresponding PCs. If you look at Albania is the first principal component score is negative 0.96. If you'd like just to see this one, you can actually do whatever you'd like. You can look at. You can create shorter lists. We can do subsetting here. New data. Let's exclude from 2 to, let's say, 8. Because here we have, this is the second, third, fourth, fifth, sixth, seventh, and eighth. You can do some subsetting, do whatever you would like. No data is not found. Yes, it's not small letter. So we just have the countries with their corresponding PCAs. Or if you like to look further, closer, you can look at only, I don't know, the first Albania with all of the PCAs. Or if you'd like to look at further, you can just look at this. No, first, second. Here you go, Albania with its PC1. So this is the principal component analysis.